Hey, welcome to day 2 of Systems of Inequalities. If you haven't watched day 1, go back, watch day 1 so that this one makes some sense, okay? In the last video, we didn't write concrete steps. I just kind of wanted you to see it in practice a little bit, but we do want to write some steps down in your notebook so that you have it to refer back to. You're going to see some more challenging systems of inequalities today, just needing a little bit more work involved. So I want to make sure you have steps for easy, medium, and difficult inequalities, okay? Some general steps. So here's going to be step 1, always, always. You are going to want to convert or change, if you rather write the word change, convert inequalities to slope, intercept form if needed. And if you want to remind yourself, slope intercept form is y equals mx plus b. And of course, there won't be an equal sign. There might be a less than or greater than or equal to sign, but still we want to rearrange it so that y is isolated on the left, so that you know where to plot your intercept and you know what the slope is, okay? So if it's not in slope intercept form, that's your first task, is you gotta rearrange some stuff. Now, when we're doing our rearranging to get y by itself, there might be a chance that you have to flip the inequality symbol. Do you remember when? If you multiply or divide by a negative, you have to flip the sign. Okay, that's a rule of inequalities. So you're going to want to make a little note to yourself, and you can use highlighter or, I don't know, make it stand out somehow, because it's definitely like a common mistake that kids make, because they forget to flip the sign if they multiply or divide by a negative. So you're going to remind yourself, if you multiply or divide by a negative, flip the sign. Okay. So that's going to be step 1. You get your inequalities nice and pretty and ready to be graphed. Okay. And step 2, graph first line. And then this is where you got to be careful whether it's solid or dashed. Graph first line and lightly shade the solution area. Okay, when it's that first line, you're just going to lightly shade it, okay, because the whole area isn't going to be the final solution area. You have to see where your overlap is, okay, so you're just going to lightly shade it. Okay, step 3 then is to graph your second line. Graph second line. And we got to pay attention to whether it's solid or dashed. And then once again, you're going to lightly shade the solution area. Okay, so once you have both lines graphed with their individual solution areas, then step 4, and I'm definitely making up this word. I don't think it's a word. Like darkly shade your overlapped area. It's not a word, but I'm going with it. Instead of lightly shade it, heavily shade it. That's better, but whatever. I already wrote it. Don't hate me. So darken, heavily shade, whatever you want to say, the overlapped area. Okay. And I want you to mention something about that overlapped area. I want this in your notes. The overlapped area is your solution area. Okay. So darkly shade the overlapped area. That is your solution for the system. Okay, so that overlapped area is where it works for both inequalities. That's where your possible solutions live. Okay, one thing I want to mention, because we've seen in my class, we've seen that it is possible to have no solution, right? So when we're doing systems of equations and you graph two parallel lines, they never intersect, that would be an example of no solution. Well, in inequalities, it is possible to have no solution. What it would have to be is there would be no overlap in the shading, okay? So the only way you would get that where the shading doesn't overlap is if you had parallel lines that were shaded kind of away from each other. So picture parallel lines, they could be shaded towards each other. They would have solutions. Anything in between them would be a solution, okay? But if they go lower than this line, but above this line, there's no overlap, and that would be a no solution. So go ahead and make yourself a little note. If there are if there is no overlap, then there is no solution. Okay, if there's no overlap in your shading, then there's no solution. It doesn't happen often, but it could happen. Okay, so those are your steps, okay? Before we graph, I do want to practice just two little converting because some of us still struggle with that. So we're just going to call this little section converting the slope-intercept form. I'm going to put y equals mx plus b. Okay, even though it's not equals, it's going to be an inequality. We get the picture. Okay, we're going to do two little examples of these just so you can get some practice and going, oh yeah, okay, I remember this. All right, so here's our first one. 8x minus 4y is less than or equal to 12. It's not a system, it's just a single inequality. But let's practice converting that to slope-intercept form. I want that y to stay there. I want the y to be on the left of the symbol, but I don't want any of this other stuff hanging out with it. So the first move you're going to make is to move your x term to the other side. We want this x to be on the other side. So I'm going to move that entire term, the 8x. Since it's positive, I'm going to subtract 8x. Whatever I do on one side, I have to do to the other. 8x minus 8x cancels out. I'm left with negative 4y. I drop down my symbol, and this is where some of you got to be real careful. 12 minus 8x is not 4x. You can't put them together. They're not like terms. I suggest putting your x term next because we want that x term right there. So I'm going to put my negative 8x right there, and that's a positive 12, so plus 12. Okay. Last thing we would need to do is divide by whatever's attached to the y because we don't want negative 4y, we just want y. So let's divide by negative 4. But if I'm going to divide this term by negative 4, I got to divide every single term by negative 4. On top of that, you just divided, or we just divided by a negative. So that's another thing you have to think about is, divide by a negative, got to flip the sign. So this now becomes a greater than or equal to symbol. Okay. Okay, let's see what simplifies. So -4 divided by -4 is 1. 1y is just y. -8 divided by -4 is +2. So my slope is 2. So we got 2x there. And +12 divided by -4 is -3. So my final inequality here in slope-intercept form would be y is greater than or equal to 2x minus 3. Now, just to kind of bring this around, let's think about whether this would be a solid or dashed line and where we would shade. That's greater than or equal to. Because it can be equal, that's a solid line. Because it's greater, you're going to shade above. Okay. Let's do another one of those. Number 2, x plus 5y is greater than 10. Okay. It's not currently in slope-intercept form. First move I'm going to make is to move that x term to the correct side. So I'm going to move that x over. How I move it, though, is I'm subtracting it. And what that means is over on the right side, it's now going to become a negative x. So on the left side, it was positive x. If I move it to the other side, it becomes negative x. So now we have 5y is greater than -x plus 10. Okay. To get y by itself, we divide by whatever's attached to it. I got to divide everything by 5 then. Okay. You just divided by a positive. Do you need to switch the sign? No, leave it. So we have y is greater, and then here's another area where I'm seeing kids get stuck. You got to remember that there's a secret 1 up there, right? So it's not going to be -5x, it's -1/5 x. Okay, you put your little x to the side. 10 divided by 5 is 2. Final inequality there is y is greater than -1/5 x plus 2. So think about solid or dashed above and below. The greater than symbol means strictly greater. So that would be a dashed line. And greater means shade above. Okay, I want to just practice a couple of those. And then there's some other things I want to mention before we actually systems. We need to do a little reminder on horizontal and vertical lines. Okay, horizontal and vertical lines. So I have taught you this acronym before. Some of you, it just really doesn't stick. I hope it sticks this time. Okay. Horizontal and vertical. Here's a horizontal line, here's a vertical line. Those are the ones where they're really short looking, like y equals 5 and x equals -2, things like that. We gotta know how to graph those. And we also have to know how to graph inequalities that are horizontal and vertical. So I use the acronym HOY-VUX to help me remember which one's which. Okay. So if you have a y equals equation, like y equals 5, so just like some number, it's not mx plus b, it's just like y equals -3, something like that. Then I think of HOY. That tells me it's going to be a horizontal line. Oops, spelled that wrong. Horizontal line. It tells me that it has a slope of 0. Okay, it's flat, slope of 0. And then if I have an x equals equation, so like x equals 2, or x equals -10, there's no y involved, it's just that, then that tells me it's going to be a vertical line. Vertical lines are kind of weird. They don't have a slope really, they have an undefined slope. Okay, so up and down, undefined slope. So that's my little acronym that I use to remember which one's which for the y equals and the x equals, horizontal or vertical. So I want to give you kind of two examples of some horizontal and vertical inequalities, okay? So let's look at if we had to graph x is less than or equal to 5. I just kind of want you to think about what that would look like. Tell yourself first, would that be horizontal or vertical? Because it has an x, it would be vertical. It'd be straight up and down. Okay, straight up and down. So we're going to say vertical line going through. Okay, so it's a vertical line, but I want you to kind of think about where it would go through. Well, it would go through +5 on which axis? X-axis, okay? Vertical line going through 5 on the x-axis. Now look at your symbol. Think about whether it be solid or dashed. Solid line, because it has the or equal to. And now think about above, shade or shade below. But in this case, you have a vertical line. Let's go ahead and draw what we have so far. Just draw a quick little baby sketch of the XY coordinate plane. So let's say we'll call this 5 right here. Here's 5 on your x-axis. If you were to draw a vertical line through 5, it's a solid line. We want to show all the solutions that are less than or equal to 5. So solid line shows the ones that are equal to 5. But where would we shade? What do you think? Left or right? It says less than. So the number is less than 5 on the x-axis or to the left. So it would be this way. Okay, that's how you would shade it. So solid line shaded to the left. If it was x is greater than 5, then you would go shade to the right. Okay. All right, here's number 2. Let's say we had y is greater than -2. Would this be horizontal or vertical? Be horizontal. And it'd be going through where? Where would it be going through? It'd be going through -2 on the y-axis. Okay. So let's draw the start of that. So here's -2 on the y-axis, or I'm going to pretend -2 is on the y-axis. And then before I graph my line, think solid or dashed. Doesn't have the or equal to sign. So it's going to be dashed line. So we'll go ahead and draw that in, dashed line. And then if it's greater, would you shade above or below? Because this one's flat like that. So there is an above and below. If it's greater, you'd shade above. So it'd be like this. So anything above that line. Okay. So I just wanted to kind of tie that into today. And then we're going to finish up our notes with one example. One example problem. Okay, one system. Here is the system. 3x plus 2y is greater than or equal to -2. Second inequality in the system is x minus 2y is less than -4. Group it up using a little squiggly dude, okay? And before I even graph it, I have some converting to do. That was step 1 in the steps that we just wrote down earlier. We have to convert these. These are not in slope-intercept form. So I'm going to be doing that first. So 3x plus 2y is greater than or equal to -2. I'll do my work there. And then over here, I'll do x minus 2y is less than -4. Here's what I'd recommend. I recommend pausing the video, converting these on your own, and then hit play. Okay. Okay, so on this first one, to get it in slope-intercept form, I'm going to subtract the x, so subtract 3x to move it over. Now I'm left with 2y is greater than or equal to. Now I'm going to plop down my x term, which is -3x, and then put down the -2. Okay, gotta get y by itself, so I'm going to divide every single thing by whatever's attached to y. Everything gets divided by +2. Since I'm dividing by positive, I don't switch the sign. I keep it. And -3/2, literally just write it as -3/2. -2/2 is, -1. So I have y is greater than or equal to -3/2 x minus 1. If you want, you could tell yourself solid or dashed right now, above and below. Greater than or equal would be solid and above. Okay. All right, now let's do the other one. I move my x terms, I subtract x on both sides. I'm left with -2y is less than -x minus 4. I divide every single thing by -2, and since you divide by negative, you have to flip the sign, okay? So we have y is greater than, and then you gotta be careful here. There's that secret 1. So you have -1 over -2, that's +1/2. -4 over -2, +2. Y is greater than 1/2 x plus 2. Okay, and that would be a dashed line, and it would be shaded above. Okay, now let's go ahead and graph that. Once again, this is where I would just kind of recommend pausing the video and kind of graphing it on your own and then checking it when you're ready. Okay, first one. I have an intercept at -1. I'm going down 3, right 2. I'm also going to show this direction. I can go down 3, right 2 for -3/2. I can also go up 3, and I'd have to go left 2. Okay, that's a solid line. And I get a shade above it. So I'm gonna lightly shade above it. Using markers, it's kind of hard to go like this. Okay, this other one has an intercept at +2, positive slope of 1/2, up 1, right 2. I could also go down 1, but I have to go left 2. Remember, we're not looking for the intersection point on these. We're looking to see the overlap shading. This one is dashed, so be careful on that. Make sure you did a dashed line. And it's shaded above because it's graded. So anything above that line. Okay. All right. Now we darkly shade. I know that's not a word, but heavily shade the overlapped area. So where on my paper, the pink and the purple overlap. So I'm going to go in with some orange here. So I'm going to show you. Change my going in with some teal blue. Anything right in there. And of course, above that would be a solution. So we had to be above both lines. So there's your solution area, okay? Possible solutions. So I am going to have you enter in your answers on Delta Math. Possible solutions. Which of the following, actually, I don't know. I kind of want to talk about this. I changed my mind. You're not going to enter your answer on delta. I want to know which of the following are possible solutions. Okay, so your options are 2, 2, 4, 1, -2, 2, 1, 4, 0, 2. I want to talk about it, so pause the video, try that out yourselves. Okay, and you're going to select all that apply. There might be more than one answer. Okay, here we go. 2, 2 is right here. It is not in the shaded area, the overlap area. It works for one of them, not for both. So that's not a solution. 4, 1, 4, 1. It's not in the overlapped area. That's not a possible solution. -2, +2. Okay, so that's on the line. Sometimes if it's on the line, it is a solution for the system, and sometimes it's not. Since it's on a solid line, that means it is a possible solution because it works for the pink line and it's also above the purple. Okay, so that's a solution because it works for both inequalities. 1, 4, 1, 4, that's definitely a possible solution. It's in the overlapped region. And then 0, 2, 0, 2. What do you think? 0, 2 is on this line, but it's a dashed line. Dashed line is like a boundary line. It means stay off. So actually anything on that line is not a solution for that inequality, which makes it not a solution for the entire system. So I'm just going to mention that it's on a dashed line down here, meaning it's not a solution. Okay. Okay. Delta Math does not have practice for graphing systems that aren't in slope-intercept form. So lucky you. I'm still going to have you practice graphing single ones though. Just, I would look at this just so you can get in the habit of changing it to slope-intercept form and knowing how to graph it. Okay, so you will practice that on Delta. Alrighty. Okay, see ya. Thanks for watching. Bye guys.